This is a video, a quick version of the lesson from Thursday and Friday. What was that? March 23rd and March 24th. So we've been working on graphing inequalities in two variables. So there'll be an x and a y in the equation, in the inequality, sorry, they're not equations. So we've already done creating a table, which will work with any type of inequality. So it'll work with this type of inequality you see right here. It will also work with an inequality where y is all by itself. So we did that first. Today, though, we're going to focus on the inequalities where y is all by itself, because we can use the y-intercept and the slope to do those. So I'm going to show you a quick reminder of how we do inequalities when y is not by itself. So I'm doing this problem right here, number 7. I'm going to zoom out a little bit. I think that probably would be better. Yeah, that's probably better. So whenever we have an equation, any equation, any inequality, the values for x and y that make the left side equal the right side. So if we wanted to make this side here equal this side, again, don't worry about the symbol. Don't worry about whether it's greater than, equal to, less than, equal to, any of that. The values that make the left side equal the right side are the values that create the line. Every point on a line makes the left side equal the right side. So when we first started equations, that's all we needed, because in an equation, we have an equal sign in between the left and the right. So therefore, we only cared about the values that made the left side equal the right side, because we had an equal sign. Now, though, we're doing inequalities. So you see our symbols are no longer equal signs, right? So now we have to take something else into account, but we do that with the shading at the end of the problem. We still need to create the line by thinking about what values make the left side equal the right side. So what we said we could do is create a table of x and y values. Always start with 0, we said, because that just typically will make our math easier. So if I want to find out, so this is basically saying for this particular inequality, I want to make the left side equal to the right side. Well, what if x was 0? If x was 0, what would y need to be to make the left side equal the right side? That's basically what a table of values is doing. So in order to figure out, now I could randomly guess at two values, try to randomly pick an x and a y and just see if they happen to make the left side equal the right side. And that's what a lot of students are doing. You don't just randomly pick two values. You pick one value, and it can be for x or for y. You plug that in, and then you solve for the second value. So like I said, we always want to pick, well, again, typically we want to pick zeros. 0 makes my math pretty easy most of the time. So I'm picking 0 for x. So if I want to solve it out, I would say 5 times 0. So I just plugged in 0 for x, subtract y. And again, I'm thinking of this as equals 5. Even though the symbol isn't equals, when I create the line, that's really what the line is. It's the values that make the left side equal the right side. Now I just solve. 0 subtract y equals 5. Again, you can see how that kind of made my math easy. That's why I picked it. So I have negative y. 0 subtract y is negative y equals 5. You remember back, anytime we have a variable with no number, there's really a 1 there. So my last step is divide by that negative 1. So that would be negative 5. So y would equal negative 5 when x was 0. Because again, remember, we picked x of 0 right there. So when x is 0, y was negative 5. That's my first point that's going to be on this line. Let me go ahead and use this eraser, I guess. So now I need a second point. We need 2 points in order to create a line, always, unless it's not a straight line. We're doing linear inequalities, which means it's a straight line, so we just need 2 points. Get rid of all of this. So now, I could pick any number I wanted for either variable right now. I could pick 1 for x, I could pick 10 for x, I could pick 1 for y. I'm going to pick 0 for y. In this case, that's going to work out really well. Also, whenever it tells you to graph standard form, or if it tells you to graph using intercepts, if you'll remember, an intercept always has a 0 in it. So this first point is an intercept. It has a 0 in it. It's the y-intercept because when I plot it, it will be right here on my graph. It'll be on the y-axis. If it's on the y-axis, it is a y-intercept. So that is a y-intercept. If I plug in 0 for y, like I'm doing right here, and I solve for x, this will be an x-intercept. It's going to wind up being on the x-axis. So that's the x-axis, that's the y-axis. Oh, shoot. Let me go ahead and erase this. Wait. Oh, this is what I want to do. All right. So now I've plugged in 0 for y, or I'm going to plug in 0 for y. That's basically saying if y was 0, if this y right here, if that's 0, what would x need to be in order for the left side to equal the right side? So I'm just going to plug it in. So I would still have the x now because I'm not replacing x. Now I'm replacing y. So I put in 0 for y. I'm thinking of it as left side equals the right side because, again, the line I create are all the points that make the left side equal the right side. We'll take care of the greater than symbol when we shade. And actually when we do the dashed or solid on the line. Oh, shoot. I forgot. I always forget this. I've changed the order to be the first step is to see if the line is dashed or solid. So I should have already done this. I didn't. The way you figure that out is you just look at the symbol. If the symbol has the or equal to part underneath it, it's solid. If it doesn't, so these two symbols, it'll be a dashed line. So I've moved that to the first step. I'm very used to doing it as the second step, but you should change your order and make sure, because it'll save you from forgetting to make it a dashed line later if it's supposed to be dashed. You can always go back and rewind the video if you didn't write that down yet. So the line here has the little line underneath it. So if I erase this, you see I have the little line underneath right there. I have that little or equal to part. So that means this is going to be a solid line. So I can write solid, just remind myself. Normally you're going to make a solid line anyways. It's probably not that big a deal. So now I want to finish solving. So 5x subtract 0 is just 5x. Divide by 5, divide by 5. So x would have to equal 1. This will be an x-intercept because it's got this ordered pairs, 1 comma 0. It has a 0 in it, which means it's an intercept, and it's going to be on the x-axis, which means it is an x-intercept. So that's my line. Or those are my 2 points that I need to create the line. That's all you need is 2 points. So now I want to draw a super straight line through those. So I'm actually going to use the line tool. I've already created it. We know it's a solid line, so I'm good there. That's close enough. Actually, tell you what, let's move it up a little bit though. You want to draw a line all the way across the graph whenever you do this. So that should, wait, that's not right. 1 comma 0 and 0. All right, yeah, that looks good. All right, so now the last step. So we've already taken care of, is the line solid or dashed? We've taken care of actually creating the line. Now we need to say, okay, one of the 2 sides of that line, either above the line or below the line, or you can sometimes think of it as left and right, which is the case here. One of those sides is the solution side. Every point on that side is a solution. The other side doesn't have any solutions. You'll never have some solutions on one side and some on the other side. So I'm going to go ahead and I always test the point 0, 0. That point right there. Just because it makes my math easy, as you'll see in a second. I'm going to get rid of some of this stuff. Hold on just a second. Because I'm going to use this side over here. So we already did that. That was step 1. Tell you what, I'm going to write step 2. Create the line. So step 2 is create the line. And there are different ways you do that. We just did it using a table. And step 3 is shade. So to do step 3, we want to test, and you should have all these steps written down from other lessons. We want to test 0, 0 just because it makes our math easier. If this point right here, point 0, 0, if that is a solution, every point on that side of the line is a solution. If it's not a solution, then no points on that side are solutions. So if we just test one point, that's all we really need to do. So, and what testing means is it just means plug it in. Plug in 0, 0. So that point right there is 0, 0. X is 0, Y is 0. See if it makes this statement true, this statement right here. If it makes it a true statement, then it's a solution. If it doesn't, then it's not a solution. So I'm going to plug in 0 for X. So that's what I just did there. 0 for Y. And I'm going to see if it makes that statement right there, or if that is a true statement. So now you'll see why it's easy to use 0, 0. This entire left side just goes to 0. 5 times 0 is 0. 0 subtract 0 is 0. I still have that, and I still have the 5. So now that you come up, you should always get a number on the left and a number on the right. All your variables should be gone for this step 3. I say to myself, is that a true statement? And I think, okay, is 0 greater than or equal to 5? If you have negatives and you're not sure, you can always use the Y number line. The higher the number, the bigger the number. So 0 is here, 5 is here. So no, 0 is not greater than or equal to 5. And it has to be one or the other. It either has to be greater than or it has to be equal. Well, it's not greater than and it's not equal. So that is a false statement. False. If it is a false statement, then 0, 0 is not a solution. So that means the other side of the line is the solution side. So I go over to the other side and I shade the other side. That is my solution side. If you really want to make sure, and it's not a bad line or not a bad idea, you can test a point that's in that solution area or that's on the other side of the line. So I'm going to do that just to show you. I'm going to test this point right here. Whoops, let me change to normal pin. That's the normal pin, yeah. So I'm going to test this point right here. I'm picking that because it has a 0 in it, which again will probably make my math a little easier. I will say, is 2, 0 a solution? That's the red point I just put. That's 2, 0. Well, if X is 2, it'd be 5 times 2. Y is 0, subtract 0. That should be greater than or equal to 5. If I do the math, 10 subtract 0 should be greater than or equal to 5. So I get 10 is greater than or equal to 5. Well, that is true. That statement is true, which means yes, 2, 0 is a solution, which it should have been because we had already determined that was the solution side. All right, now, if you want, you should be able to do any inequalities using that process, using a table of X and Y values. I'm going to show you the other way you can do it, though. We did this before when we did equations. You can do it. You can also do it with inequalities. If we want to make the line when Y is all by itself, that is the key to do what we are about to do. Y has to be all by itself. You cannot use this method if Y is not all by itself. You cannot use it here. Y is not by itself. It's got that stuff with it. You can't use it here. Y has all that stuff. You could use it here because Y is all by itself. You cannot use it here. So again, Y has to be all by itself. Like there, Y is by itself. Y is by itself. Y is by itself. Cannot do it in number 3. So we need to use the y-intercept and the slope. So the y-intercept is the number all by itself, not with x. So y-intercept not with x. The slope is with x. So this is the y-intercept. This -2, and I hate that they use the same number, that -2 is the slope. So the variables we use for those are m and b. So what, I will color coordinate this. So the slope number, hold that thought. We'll make it, I guess we can make it black. So the slope number we will put in red. How am I going to do this though? There we go. So the slope number we'll make in red. So -2 is the slope. But you'll notice that red matches up with red. And the -2 that is in black represents the y-intercept. So I'm going to make a point. So my very first step is I need to just put the y-intercept on the y-axis. Get rid of some of this. You can always go back if you need to. So the y-intercept is this black -2. It's the number that's not with x. So I showed you that earlier. I'm not going to show you again. I just put a point on that number. There you go. That's my first point that's going to be on the line. If I plug 0, -2 into the equation, it will make the left side equal the right side. You can do it real quick if you want. Actually, I'll even do it for you. I didn't do it in class, I don't think. So 0, -2 would be -2 should equal -2 times 0, subtract 2. If you do that math, you get 0, subtract 2 on the right. And yes, you get -2 equals -2. Again, every point on the line makes the left side equal the right side, which that point does. So now, the black -2 is the y-intercept. We need a second point. We have got to figure out where the next point on the line is. We don't have any calculations that we have to do in this process, unlike when we did the table of x and y values. We just need to say, okay, well, I know that there's a slope in here. It's the red -2. I also know the formula for slope is rise over run. Well, if I know the formula for slope, I know that the slope is -2. I can use that information to find the next point on the line. The trick is, in this particular problem, I need to create a fraction. Right now, I just have a rise number. I just have -2. So I need to make that into a fraction by putting it over 1. Any number can be made into a fraction by putting it over +1. Whenever you have a fraction already, like here, we already have a fraction, you don't need to do that step. You already have a rise number and a run number. One thing I would make sure of is make the top number, if the fraction is negative, make the top number the negative. So I would make that -1 over 3. This way, if your bottom number, your run number is positive, you always go to the right. You'll never, ever make a mistake. You'll just always know your run number goes to the right. Then you just have to figure out, do I go up or down for the rise? All right, so back to number 1 over here. Now that I have a rise number and a run number, I would tell you always do the run first. If not, you might get confused with another lesson that we do in algebra. So just always do run first. I'm going to zoom in a little bit to this. All right. So if my run number is 1, so positive 1, that means I'm going to go right 1. So I go right 1. If my rise number is negative, and you may have noticed that I had these written down in the upper right corner, I'll show them to you again in a minute. Hopefully it makes logical sense that a positive rise would mean you're going up. You're getting more positive, you're going up. So therefore a negative rise would mean we'd have to go down. We'd have to do the opposite. So when I do that, there's my second point. I didn't have any calculations. I just had a process I had to follow. Oh, and I forgot to do this again. I should have at the very beginning looked at my symbol. I didn't. And I should have written whether this line needs to be dashed or solid. In this case, I do have that little or equal to, so it's going to be solid. So now I've created my first 2 points. I don't need more than 2 points. If you want to do 3, just to make sure you can. So that's where the line would go. So now that I have my line, the last step is the same. I do the same exact thing I did before. The only time you can't use 0, 0 to test is if 0, 0 is already on the line. If 0, 0 is on the line, you have to pick another point. But in this case, 0, 0 is not on the line, so I can test it to see if this side over here, I want to see is this side the solution side or not. You don't just automatically shade 0, 0, by the way. Some students just always shade 0, 0. So in order to test it, I just plug in 0, 0. So y is 0. That's greater than or equal to. Don't ever change the numbers in an equation or in inequality. Sometimes kids are changing the numbers to be 0. You cannot do that. X and y are changed to 0. So the negative 2's stay in there. I get 0 is greater than or equal to 0 subtract 2. And then I get 0 is greater than or equal to negative 2. Again, if you're not sure if that's right, look at the y-axis. The higher number is the bigger number. Well, 0 is right here. Negative 2 is right here. So yeah, 0 is higher, so 0 is greater. So yes, that is a true statement. So if that is a true statement, now I'll zoom back out, then that means 0, 0 is a solution, which means this side where 0, 0 is will be the solution side. Every number on this side will work. Every ordered pair on this side will work. No ordered pairs on the other side should work. If I really want to, I can test that out. So let's do that real quick. We'll say, all right, well, what if I plugged in this point right here, negative 2 comma 0. I'm doing that because, again, it's got a 0 in it, which makes my math a little easier. So negative 2 comma 0 would mean I would put 0 for y. That should be greater than or equal to negative 2 times negative 2, because x is negative 2 at this point right here. And then subtract 2. If I do the math on that, I'll just write it over here to the right. I get 0 is greater than or equal to positive 2. Because negative 2 times negative 2 is positive 4. Positive 4 subtract 2 is 2. You can do it in your calculator if you want to check that. So that does not work. That is false. 0 is not greater than or equal to positive 2. So that point did not work, and it shouldn't have worked because we had already determined the other side was the solution side. If you have questions, you can ask me in class. And you can watch the videos from the other graphing lessons if you want to get more detail.